Okay, so we'll have now our discussion on the introduction to engineering data analysis, especially the concept of statistics and how it is useful to our everyday life, the branches of statistics, and also what are the difference of those two branches. Okay, so first we will define the term statistics. So statistics, so it is the science and the art which deals on interpreting data from facts and information. So this is one of the definition of statistics. So it is the science and the art which deals on interpreting data from facts and information. Also, we could have another definition of that. So it is a science which deals with the methods of gathering, presentation, analysis, and interpretation of data. So the other definition for statistics is that it is a science which deals with the methods of gathering, presentation, analysis, and interpretation of data. So we will now go to we'll now try to define we'll now try to define each of these methods. So we have gathering, presentation, analysis, and interpretation. So first, we will try to have a insert first a box here. Shape. Okay. Let's have it there. Okay. So the flow of statistics is first we have here the data gathering. So this is the first step. Then the next step is the presentation. Data presentation. The next is data analysis. And the last one will be data interpretation. Okay, so this is how the whole flow of statistics goes. We have data gathering, data presentation, data analysis, and data presentation. Okay, so we will try to define each of these process. Okay, so first we will define data gathering. So data gathering, it involves, let's just write first the definition. Okay, so data gathering involves getting information through, so I believe it's lacking H, okay, through interviews, questionnaires, observations, experimentation, testing, and other methods. So basically, we are trying to gather data. So there are methods of that which is involves interviews. So if you are familiar with your research work during your senior high school days, so um, you have gone to interview, or the other method is questionnaire, so in which you have given questionnaire to the respondents. Then you have observations. So basically it is observing people, or observing the phenomenon of a certain study in which you are going to get the data, or going to observe the change in its properties. We have also experimentations, then testing, and other methods. So the data that you have gathered, let's just move it up. Okay, so not too much. Okay, so the data that you have gathered will be presented in a certain way, and that is now data presentation. Okay, so data presentation is defined as the deals with translating of information into a numerical or quantitative by using tabular or graphical form. Okay, so data presentation involves, so we have, let's write first our R legibly here. So we have presentation. Okay, so data presentation deals with translating of information into numerical or quantitative data by using tabular or graphical form. So after the data gathering, so you are going to present your data into maybe a table or a graph, and that is now what we call as data presentation. For example, you are going to have a data, for example, our data for the a certain, let's say, grade, yeah? Grade. So for example, the grade is for your have one, so we have quiz, so quizzes, so this will be quiz 1, 2, 3, 4, 5. Then your first quiz is 90, then we have 89, then 75, then let's just say 50, and this will be 100. So this is a way of representing your data. So this is the data that you gather. So this will be a tabular form. We're going to have that one in a graphical form. So for example, we will use a line graph. So let's have this one. This will be the grade here. Let's say the quizzes. This will be the grade. Okay. Then this is the number of quizzes. So we have 5 quizzes. 5, so we have 1, 2, 3, 4, 5. Then let's start with 75. Maybe we'll start with 75 here. Then we go to 80. Then we will go to maybe 85. So we're running out of space. 90. Then this is 0. So for example, if you are going to graph your let's just first, so if you are going to graph this one, this will be 95 and this will be 100. So for quiz number 1, so suppose this here's our 50, so you have 90. So this is our 90. Then for quiz number 2, 89, so a little bit lower. Then for quiz number 3, this is 75. So here, so just align that one. Then we have for this 50, so here, and for 5, quiz number 5 is 100. So here, if you are going to create a line on that one, so this will be the line graph. So you could interpret this one directly. So it means that your highest quiz is 5, which is 100. So you could say that maybe this quiz you have studied, you managed to study the lesson very well, or the lesson is just easy. And for quiz number 4, in which you get 50, the lesson is hard. So this will be the graph of your grade. So that this is how you will present the data that you have gathered. Okay, so let's have some more space for after the presenting the data. So the one that I was talking about, in which I am going to interpret the data that is presented by the graph, is data analysis. Okay. So data analysis is defined as the resolution of information into a numerical I just repeated the definition of the class of the data presentation into a simpler screen, simpler elements Okay, so we have data analysis is the resolution of information into simpler elements by the application this by the application of statistical principles, the choice of which depends upon the nature or purpose of the problem at hand. Okay, so data analysis is the main core of this subject. So that's why a whole subject is given emphasis to data analysis because it is very important. So if you have your data, you are going to analyze it so that you could answer your problem. So the very purpose of a data analysis is to answer the so-called research problem. So the gist of statistics, usually the statistics is used. So statistics. Okay, so it's just statistics is usually used for research, or that is the main reason why students are obliged or required to undergo the subject which involves statistics, and that is for research purposes, especially if you are getting a degree course. So you must undergo a subject which involves statistics, because later on in your senior year or in your graduating years, so you will be tasked to do a research. So the research has a so-called research problem. Okay, so the research problem can be answered by gating the data, so data gathering. So either it is by interview or questionnaire or experimentation. Then in order to answer that one, to answer the problem by the use of data, the data must be analyzed. So that's why we will have our data analysis. Okay, so the data analysis, it will depend on the type of problem. Either it is a correlation, it is a testing of the hypothesis, or just to describe the certain data. So the data analysis is involved to answer the research problem. So that's why it is very important for students to be able to know what are the different methods of data analysis, because every method is made specifically for a certain purpose to answer a certain research problem. So there is no one conventional way to be applied to any type of research. There are different methods which is directly applicable to certain research problem, and that is one of the core purposes of having this subject, which is engineering data analysis. Okay, so the last one is data interpretation. Okay, so in data interpretation, so it comes after the data analysis. So this includes findings, and relating that findings Okay, so we have data presentation. So it involves, so it is, it comes after, so it's just comes after. Okay, so it comes after data analysis. So this is not F but D. So data analysis. So it includes finding and relating those result of the data analysis, which is called the findings, to existing theories and earlier study on that area. So basically we are interpreting what is the result of the data analysis. For example, in your study, that if you are good in math, so if you are good in math, you are bad in English. Okay, so first, let's say that you found that there is a direct correlation, or there is a direct relationship, and it was proven by your data analysis. So these findings, so this will now be your findings. So these findings must be supported, or must be related, or we must find a way to relate this one to existing theories. So that's why if you are having a research project or a research study, so you must relate your findings into your RRL, or your review of related literature, in which on this RRL you will find your existing theories. Okay, so it is not a rule that your findings must be the same with the existing theory, or must be on agreement with the existing theory, but rather it could be against the existing theory. So it depends on the result of your study. If your findings is in agreement with the existing theory, so you cite the factors, or you cite the characteristics of your data or of your findings that in agreement with the existing theories. If it is against the existing theories, you will also cite the characteristics or the factors of your findings. Okay, so those are the branches, or those are the processes in statistics. So there are also two types of statistics, and I believe you have known this one during your senior high days. So we have the types of statistics. So there are two. So first we have the descriptive. So the descriptive statistics. So it's involved the, so it summarizes the data, Okay, so descriptive statistics so summarizes data numerically and or graphically. Then the results are interpreted using mean and standard deviation. So basically, you're just describing your result. So for example, if the the average of of a certain uh, class, their mean or their average is 85%, so meaning you are going to describe this one that the whole class, their average grade is above the passing, which is 75%. So that is how the simple way on how descriptive statistics works. So if you are going to have a standard deviation, so for example the standard deviation is 2.5, so meaning 2.5 of the class, are deviates from the mean. So meaning there is a longer there is there is a greater chance that more students are on the above above average or above the 85% grade. So that is how descriptive statistics work using the mean and standard deviation. Of course, we are also going to discuss this further during our discussion of the measures of central tendency. So we will know far more about mean, standard deviation. Also, we have the mode and the median. The next one is inferential. Okay, so inferential is just it involves the generalization of the findings of a sample of a population. So let's just have this one, population to make conclusions. About the nature of the whole. Okay, so problem in our pen of the whole So, in inferential statistics is the generalization of findings of a sample of a population to make conclusions about the nature of the population. So, basically, you have a findings of a certain number of a certain sample of a population. For example, we have 1,000 of 1,000 respondents out of, let's say, 1 million. Then during your data gathering process, data presentation and data analysis, you found out that 90% of them, so 90% of the 1,000, we are in favor of online class, okay. So you could make a conclusion that also 90% of the 1 million can is also in favor of online class. So that is inferential. So you are making inferences. You are making conclusions of your findings based on your findings from a sample or a representative of the population, of the whole population, uh, that will be applicable to the whole population. So that is how inferential statistics work. Okay, so on our next topic we are going to discuss what is a data. Then we will go a little background history on statistics, then data, the types of data, and the methods of the methods of gathering data. Okay, so thank you for watching this video. So sorry for my penmanship. I hope you understand our discussion uh, for for today. So again, enjoy learning.